So today, we are pulling back the curtain on one of the biggest, most clever breakthroughs in all of modern AI. We're going to reveal the secret. It's almost like a heist story that taught computers how to see the world not just as a bunch of pixels, but as a story that it could actually read.
Have you ever wondered how your phone just knows? You type dog or beach into your photo library, and in less than a second, it finds every single picture you're looking for? It feels like magic, right, doesn't it? But it's not. It's all thanks to a revolutionary idea that completely changed the game for how machines understand images. And today, we're going to break down exactly how that trick works.
All right, let's get into it. To really appreciate just how brilliant this new idea is, we first have to talk about the old way of doing things. You see, for years, the king of computer vision was a method that worked kind of like a very careful, but also very nearsighted scanner. This old method is called a convolutional neural network, or a CNN. Just imagine it starting in the top left corner of a photo. It looks at a tiny little square of pixels and tries to find simple stuff, like a sharp edge, a spot of color, or a bit of texture. Then it just slides over to the next square and does it all over again, and again, and again, slowly piecing together these little details into bigger shapes, until finally it can make a guess about what it's looking at.
Now, this scanner approach was actually great at recognizing small, local details. You know, the texture of a dog's fur, the pattern on a basketball. But it had one huge weakness. It really struggled to see the big picture right away. It had a tough time understanding that a dog's ear over on the left side of the picture was related to its tail way over on the right side, without building up all these layers of context first.
So, this weakness is what set the stage for a massive aha moment. A group of researchers at Google had an idea that was so simple, but so incredibly powerful, it was about to change absolutely everything. They basically planned a heist. They looked over at the world of language AI, where this powerful new tool called the transformer was making waves by reading entire sentences all at once. And they asked a simple question. What if we could steal that idea? What if we stopped scanning images piece by tiny piece and instead treated a picture like it was a sentence and just read it? So how on earth do you read a picture? Well, the strategy they came up with is something I like to call the expert art appraisal team. Okay, so step one, you have to break the masterpiece down into smaller, manageable chunks. The AI literally slices the image up into a grid of little squares, or patches. And here's the absolute key. Each one of these patches is now treated like a single word in our brand new picture sentence. So here's how this appraisal team works. Every single one of those picture words gets handed off to a different specialist. Then, they all hop on a giant conference call. And on this call, every specialist describes what's in their little patch. But, and this is the crucial part, they're all listening to every other specialist at the exact same time. This lets them find connections instantly. The specialist looking at a furry ear can immediately link up with the specialist looking at a wagging tail, no matter how far apart they are in the photo. This conference call, well, that's the secret sauce. In the AI world, it's called the self-attention mechanism. It's the process that lets every single patch look at all the other patches at once and figure out which ones are most important to each other. This is how the AI gets that big picture understanding in a flash, something the old scanner method just couldn't do. But, okay, after all this chatter, who makes the final decision? Well, the team has a head appraiser, a special expert who's also on the call. In the AI, this is an extra little piece of data, an extra word that doesn't actually represent any part of the image. Its only job is to listen to the whole conversation and then, based on everything it heard, deliver the final verdict. Yep, this is a dog. And this whole brilliant strategy, this team of experts reading a picture like it's a sentence, it has an official name, the Vision Transformer, or ViT for short. It was literally taking the transformer from the world of language and just applying it to pictures. So the plan was brilliant, right? A totally audacious raid on an idea from a completely different field of AI. But did the heist actually work? Did this new team of art appraisers really do better than the old trusted scanner? I mean, this was the billion-dollar question. For decades, those scanner-like CNNs had been the undisputed champs of computer vision. Could this totally radical new idea, which had zero built-in knowledge of how images even work, really stand a chance? Well, here's the twist. At first, the answer was, surprisingly, no. When they trained it on a kind of normal-sized dataset of about 1 million images, the Vision Transformer actually performed worse than the old methods. Why? because it didn't have any cheat sheets. It had no built-in assumptions, so it needed a truly massive amount of data to learn the absolute basics of vision from the ground up.
But then, the researchers fed it a colossal dataset, 300 million images. And when they did that, the whole story changed. With enough examples, the vision transformer didn't just catch up, it started to completely blow past the old methods. The takeaway was clear. For huge datasets, letting the AI learn the rules directly from the data is way more powerful than giving it a head start.
And the final results? They were just stunning. Their best model hit an accuracy of 88.55% on the gold standard ImageNet test. It had officially beaten the best scanner-style model. The heist was a total success.
But here's the real kicker. It wasn't just more accurate. It was also way more efficient. The Vision Transformer got these world-class results while using up to 4 times less computing power to train. Think about that. It was better, faster, and cheaper. That's not just a heist, that's a clean getaway.
So why does a research paper from a few years ago matter to you right now? Because that technology, that brilliant idea they stole from language AI, it isn't just sitting in a lab somewhere. It's probably in your pocket right now. The Vision Transformer is now the backbone for how so many of the AI tools we use every single day actually see the world. It's what's powering the search in your photo app. It's the vision in huge models like GPT-4 that can understand images you show them. And it's a key ingredient in text-to-image tools like Midjourney that create unbelievable art from just a few words.
Okay, so let's bring this all home. After this whirlwind tour of scanners and heists and expert art appraisers, what's the one big idea you should walk away with?
When you boil it all down, it comes to this. For decades, we taught computers to see by having them scan for tiny details. But the real game changer was when we taught them to just step back and read the entire picture like a sentence, to understand the context and how all the parts relate to each other all at once. We taught them to see the whole story, not just the individual words.
This single idea didn't just beat a record. It completely changed the future of AI and unlocked the incredible visual tools we see all around us today. And it leaves us with a really exciting question for the future. If computers can now read pictures, what on earth will they learn to see next?